The deadly threat to people's lives posed by the powerful Cascadia earthquake that shakes the Pacific Northwest may not come from the ground itself, but rather from what is discharged into the atmosphere. According to emergency personnel in Multnomah County, a 9.0 magnitude earthquake, which scientists predict might occur in the next 50 years, would probably cause industrial sites to spew fatal plumes of dangerous pollutants. These plumes have the potential to kill and harm tens of thousands of people, depending on the weather and time of day. In a report presented to the Multnomah County Board of Commissioners this month, emergency managers gave the bad news and provided few immediate options. To gain a more thorough picture of the region's danger of chemical exposures during a megaquake, they advised county authorities to collaborate with other county, state, and federal officials. To help residents of high-risk locations learn the best ways to protect themselves, they also suggested a public education effort. The report also advises the county to think about writing and supporting a bill for a statewide investigation of hazardous pollutants at industrial facilities. Jessica Vega Pedersen, chair of Multnomah County, announced that she would send the findings to Governor Tina Kotek along with a letter urging an urgent public policy response. At the board meeting on October 12, she declared, "My colleagues on this board and I will not be satisfied with platitudes or promises. We will work toward the solutions these threats demand of us and ask the state to respond to this crisis quickly and carefully." A bill requiring industrial hubs in northwest Portland to start submitting seismic hazard evaluations to the state was passed by state lawmakers last year. The Critical Energy Infrastructure Hub, a grouping of these facilities, is situated along a 6-mile section of the Willamette River. There are 415 operational storage tanks at the hub, via which 90% of the state's gasoline supply is transferred. 91% of them were constructed prior to 1993, the year the state began enforcing fundamental seismic criteria for chemical storage. According to a report from 2022, these gasoline tanks are likely to sustain damage after a significant earthquake, given their age. Almost half of the petroleum product that would be released from the hub might flow into the Willamette River, according to that report's estimate of 95 million to 194 million gallons. A significant number of fires are predicted to start. The fear of those fires spreading to Forest Park, where more than 70,000 people reside, may materialize under the ideal circumstances. The emergency managers of Multnomah County evaluated more high-risk industrial sites throughout the county for this month's report, many of which are gathered in North Portland, close to the confluence of the Willamette and Columbia rivers. As a result of liquefaction, that region is also the most susceptible to devastation. When an earthquake shakes the ground near bodies of water, it disrupts the soil and can threaten above-ground storage tanks holding fuel and chemicals by causing a quicksand effect. If that occurs, poisonous plumes might spread throughout a large portion of the county and beyond, causing injuries ranging from minor eye irritation to fatal respiratory issues. Up to 2,500 people could perish, and 17,000 people could be hurt in Multnomah County under the right circumstances, such as a hot day with little breeze, the report states. Eye discomfort may affect an additional 330,000 persons. The forecasts were developed by county emergency management professionals in collaboration with researchers from Portland State University and other governmental organizations. 27 of the top 70 industrial facilities in the county with the highest risk were found in North Portland. These facilities keep a variety of potentially harmful chemicals, such as fuel, sulfur dioxide, hydrogen chloride, hydrochloric acid, and sulfur dioxide. The storage facilities were built on top of terrain that will probably liquefy following a severe earthquake, according to Emergency Management Director Chris Voss. "We have a history here," Voss added after pausing. "On our most toxic soils, we have a history of using dangerous chemicals." According to Voss, a lot of these facilities picked North Portland because of its accessibility to rivers and ports. Land use planners weren't yet aware of the area's high danger of liquefaction when they were constructed. It wasn't until 2010 that experts predicted there would be a 1 in 3 possibility of a megaquake occurring in the Pacific Northwest during the next 50 years. According to Voss, another factor contributing to the concentration of industrial facilities in North Portland is the traditionally low cost of the land. In comparison to the rest of the county, the area also has greater poverty rates. Census data show that 22% of people in the 97203 zip code, which includes St. John's neighborhood, where experts estimate a substantial concentration of deaths attributable to post-earthquake chemical release, live below the poverty line, compared to 12% in the county as a whole. As a result, the post-earthquake chemical plumes pose the greatest hazard to some of the county's most economically vulnerable residents. The paper focuses on 4 facilities in North Portland and depicts the potential spread of hazardous chemicals from those sites under typical summer and winter weather conditions. The anonymity of the facility names in the study is done so as to minimize the risk of this information being used to intentionally cause harm. The researchers who wrote the report note that the chemical exposures would occur when roads are congested or earthquake damaged, making it more difficult for first responders to assist patients with severe respiratory issues. Damage to water treatment facilities could also prevent individuals from washing their bodies and eyes right away after being exposed to chemicals. A toxic airborne occurrence would typically prompt first responders to urge people to hide in place, but an earthquake might threaten many homes and structures by shattering windows and tumbling walls. Likewise, the risk of a 1-2 earthquake punch is a new addition of the threats. According to a recent study, researchers discovered the most recent significant earthquake on the Seattle Fault wasn't a solo act by using cutting-edge triggering and radiocarbon dating techniques. At around the same time, the Saddle Mountain Fault, which runs through the Olympic Peninsula close to Lake Cushman, ruptured. Likewise, the team was able to narrow down the time period with astounding accuracy, bringing it down to a 6-month period between the fall of 923 AD and the spring of the following year, almost exactly 1,100 years ago. On Wednesday, the journal Science Advances released their findings. According to Harold Tobin, director of the Pacific Northwest Seismic Network at the University of Washington, the project, which took place over the course of more than 5 years and involved divers using underwater chainsaws to sample trees that had been drowned by the earthquakes, is a scientific triumph almost unmatched in seismology. The team's new method, which looks for signs of historic solar storms preserved in tree rings, helped them narrow down the time period. However, according to Tobin, a non-participant in the study, the findings add a new worst-case scenario to the seismic hazards facing a region with 4 million residents. Particularly to ancient brick and concrete structures, weak bridges, and infrastructure, a seismic double whammy would be significantly more destructive than a single quake. Tobin continued, "It's a scenario that hasn't been taken into account in hazard maps, building codes, and emergency planning, but it needs to be. The chance in any given year is not high, and there's no reason to freak out because of this study," Tobin stated. But it underscores that these are things that we need to be prepared for. A relatively small magnitude 6.7 earthquake on the Seattle Fault, according to a 2005 analysis, might kill 1,600 people, level up 10,000 buildings, and result in up to $50 billion in economic losses. According to the new study, if the Seattle and Saddle Mountain faults rupture at the same time, the ensuing earthquake would measure magnitude 7.8, nearly 40 times more powerful, and affect a significantly larger area. Morgan Page, a co-author of the study from the U.S. Geological Survey, said that the precise timing of the historic earthquakes is still unknown. She determines a 3-to-1 possibility that the faults rupture simultaneously based on statistical study of worldwide earthquake sequences. However, it's also feasible that the 2 earthquakes occurred hours, days, or even months apart. The analysis places their magnitudes there at 7.3 and 7.5. According to John Cassidy, a senior seismologist for Natural Resources Canada, who was not engaged in the investigation, scientists used to label the majority of clustered earthquakes as aftershocks and believe they happened on the same fault. However, greater knowledge about how a mistake on one defect might stress out others has emerged during the past few years. A strong earthquake that struck Turkey in February set off the destruction there by rupturing a neighboring fault 9 hours later. Because they occur so close to the surface, shallow earthquakes adjacent to populated areas can be very destructive. Compared to Washington's most recent large earthquake, the magnitude 6.8 Nisqually event in 2001, which had its origins more than 20 miles beneath the surface, the shaking would be significantly more powerful. An earthquake on the Seattle Fault is likely to be much more catastrophic, stated Tobin. The good news is that shallow fault earthquakes are extremely uncommon in Washington. The researchers claim that the seismic mayhem in 923 to 924 AD may have been the most violent incident since the end of the previous ice age 16,000 years ago. The majority of the dozen or so faults in the region appear to rupture every 1,000 to several thousand years, according to Tobin, but geologists still don't have complete earthquake histories for most of them. A significant Seattle fault earthquake is predicted to occur in the next 50 years, with a 5% chance, according to the USGS. Tobin noted that nothing as strong as the earthquake that hit Morocco earlier this month had ever been documented because it occurred in a region with a low earthquake frequency. Over 30 years of geological discoveries have served as a foundation for the current research. The Seattle fault earthquake, which raised Alki Point and the southeast tip of Bainbridge Island by as much as 20 feet, and triggered a tsunami that flooded the location of the West Point treatment plant, left a number of traces that were discovered during field work in the early 1990s. Furthermore, it caused landslides on Merced Island, which sent old-growth woods tumbling into Lake Washington, where some are still standing upright in nearly 300 feet of water. A 24-foot-tall scarp caused by the Saddle Mountain earthquake fractured the ground, blocking a drainage and forming Price Lake, which as the water level increased, drowned trees. The key to the new study was a group of submerged trees from Price Lake, Lake Washington, and other locations that were preserved in cold, oxygen-poor water. The Seattle fault earthquake has previously been assigned a radiocarbon date that ranged from 900 to 930 AD. Interesting cues from a number of other faults, such as Olympia, Saddle Mountain, and Tacoma, showed they may have burst at the same time. The age ranges of those other sites, however, might have ranged over several centuries, according to standard methodologies. There was too much uncertainty, remarked co-author Brian Sharrod, a USGS scientist who has devoted the majority of his professional life to studying faults all throughout the state. Brian Black, a renowned dendrochronologist from the University of Arizona, and Sharrod met by chance at a scientific meeting, beginning a journey that would last for several years. It's a significant puzzle. That is the reason it took so long, Sharrod added. To me, the story is these new techniques Brian and his colleagues bring to the picture. Radiocarbon dating is not as accurate as tree rings, according to Black. The samples must, however, contain substantial ring sequences and be in good condition, with bark. Compiling the dozens of cores and wood slices that previous researchers had gathered over the years was one of the most challenging undertakings. In the end, Black managed to get acceptable samples from 47 Douglas firs at 6 locations where earthquake-caused tree flooding had occurred. A little more than 3 centuries of history were recorded in some of the samples. In Price Lake, where the quake-killed Douglas fir stumps are still visible, the team had to gather fresh samples. To cut viable samples with undamaged bark from the tree bases, USGS divers had to battle in the murky water. Black, the study's principal author, claimed that due to their lack of visibility, it could take them up to an hour to cut just one wedge from a tree. He used a reference sequence from 1,300-year-old firs that were harvested on Vancouver Island in the early 1990s to anchor the tree rings in time, making it possible to determine the date of the outermost ring. Each sample was repeatedly black-sanded, including with lapping films made of diamond grit with a micron level of grit. It's sanded to the point where you can see the individual cells within the wood under a microscope, claimed the man. The solution was obvious when he arranged his samples and contrasted them with the reference trees. By using radiocarbon analysis to seek for signs of cosmic timestamps known as megaquake events, the accuracy of the date was verified. The events, which bear the name of the Japanese physicist who first noticed them, are spikes in radiation that originated from solar flares or exploding stars hundreds or thousands of years ago. Fortunately for dendrochronology, increases in cosmic radiation also result in increases in the atmospheric concentration of carbon-14, the isotope whose slow decay serves as the foundation for radiocarbon dating. Black and his associates were even luckier since a megaquake event that took place in the year 774 AD appeared in their samples of Douglas fir, giving them an exact standard to measure their findings against. Boom, he exclaimed. Everything came together, and we saw that these trees all died, with the last completely formed ring being the year 923. Black claimed he can now understand why the Seattle fault rupture mystery, which has persisted for more than 30 years, is still a mystery, along with the question of whether other faults were involved. This has been the most complicated and challenging dating project in my career, and he and Sherrod haven't finished yet. To determine whether the earthquake that occurred 1,100 years ago was even more severe, they are looking for drowned trees that are connected to the Tacoma and Olympia faults. Old brick structures, often known as unreinforced masonry, URM, are among the riskiest locations to be in during an earthquake. In the meantime, Seattle is attempting to address this risk once more. Over 1,000 URM residential complexes, offices, churches, and meeting rooms are dispersed throughout the city, and initiatives to demand retrofits have constantly hit a wall. According to Amanda Hertzfeld, program manager for URM, the most recent change is a new rule that standardizes and simplifies the standards for retrofits. The next phase is a retrofit program that is voluntary and might be implemented by the spring of 2019. Hertzfeld noted that although there isn't presently a deadline, the ultimate goal is to enforce renovations. Meanwhile, warm liquid escaping from the Oregon seafloor is caused by the Cascadia Fault and may provide information about earthquake hazards. About 50 miles off the coast of Newport, Oregon, a study sponsored by the University of Washington found seeps of warm, chemically unique liquid rising from the seafloor. The unique underwater spring known as Pythia's Oasis is described in the report, which was released on January 25 in Science Advances. According to observations, the spring controls stress on the offshore fault by drawing its energy from water 2.5 miles below the seafloor at the plate boundary. During a cruise in the RV Thomas G. Thompson that was delayed due to bad weather, the team made the discovery. Unexpected bubble plumes were detected by the ship's sonar at a depth of around 0.7 miles below the surface of the water. The bubbles were discovered to be merely a minor component of the warm, chemically unique fluid spilling from the bottom dirt after further investigation utilizing an underwater robot. They investigated that way, and what they found was not just methane bubbles, but also water shooting up like a fire hose from the seafloor. Evan Solomon, a co-author and associate professor of oceanography at the University of Washington, who specializes in the geology of the seafloor, stated, "That's something I've never seen and to my knowledge has not been observed before." First author Brendan Phillip, who carried out the research as a doctoral student at the UW and is currently a policy advisor for the White House, was the one who initially identified the trait. The fluid emerging from the seafloor is, according to observations from subsequent expeditions, 9 degrees Celsius, 16 degrees Fahrenheit, warmer than the surrounding salt water. According to calculations, the fluid is directly emerging from the Cascadia mega thrust, where temperatures are thought to range from 300 degrees Fahrenheit to 480 degrees Fahrenheit, 150 degrees Celsius to 250 degrees Celsius. According to Solomon, the new seeps have nothing to do with the geologic activity at the neighboring seafloor observatory. As an alternative, they tend to crop up close to the vast Cascadia Subduction zone's cross-cutting faults. Strike-slip faults, where chunks of ocean crust and sediment slide past one another, are a result of stress on the continental plate caused by the ocean plate crashing into it at an angle. As the fluid pressure between the sediment particles decreases, the friction between the oceanic and continental plates increases, making it crucial that fluid be lost from the offshore mega-thrust interface via these strike-slip faults. The mega-thrust fault zone is like an air hockey table, said Solomon. If the fluid pressure is high, it's like turning on the air. The two plates will slide past one another with little resistance. The two plates can lock together and cause tension if the fluid pressure is low enough. Solomon compared the fluid seeping out of the fracture zone to leaking oil. For earthquake danger, that's not good news. With less oil, stresses can build up and cause a destructive earthquake. Solomon proclaimed that this was the pioneer location for its sort. It's possible, he said, that other sites with fluid seeps exist nearby, though they'd be difficult to spot from the ocean's surface. The Cascadia Subduction zone is split in two, with the northern part off the coast of Washington believed to be more tightly locked, coupled, than the southern section off the coast of Oregon. This difference may be explained by a large fluid leak off central Oregon. As UW oceanography professor and co-author Deborah Kelly put it, Pythia's Oasis provides a rare window into processes acting deep in the seafloor, and the composition of the fluid there implies it originates near a plate boundary. This suggests that the nearby faults regulate fluid pressure and megathrust slip behavior along the central Cascadia Subduction zone. Solomon has recently returned from a mission to measure fluid levels beneath the ocean floor in the waters off New Zealand's northeast coast. While the Cascadia Subduction Zone is difficult to examine because to its large earthquakes, the Hikurangi Subduction Zone is more manageable due to its smaller, more frequent tremors. However, Solomon noted that due to the differences in the subsea floor structure, it is highly improbable to see fluid seeps similar to those found in the recent study. As Max Mayfield says, preparation through education is less costly than learning through tragedy. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.